Welcome back to All This Math. This is Professor Parker, and for today's lesson, we're going to be subtracting mixed numbers where we have to borrow. We have to borrow because the fraction in the second mixed number is actually bigger than the fraction in the first mixed number. So when we encounter that situation, one of the methods that we use, the most prevalent method or the most popular method, is to borrow, right? So that we can make the fraction in the first mixed number bigger than the fraction in the second mixed number. All right. Also, you see I have my historically black colleges and universities matter t-shirt on, so shout out to HBCUs. All right. Let's look at the problem. We got 20 and 1/8 minus 9 and 5/8. If you notice, the whole numbers are cool. 20 is bigger than 9. And I shouldn't say cool, because even if, the first number, which is called the minuend, is larger than the second number, when you do subtraction, you would just end up with a negative value or a negative number. That's fine, but this is not what we're dealing with here. So 20 is larger than 9, okay. But then 1/8 is smaller than 5/8. These have a common denominator already. A lot of problems that you encounter, you will have uncommon denominators, and you'll have to change that in order to create common denominators between the two fractions. In this particular problem, we don't got to worry about all that because our denominators are already the same. They're already both 8. That's an 8, that's an 8. All right, so we got 1/8 and we got 5/8. But 1/8, of course, is smaller than 5/8. So because 1/8 is smaller than 5/8, we're going to borrow from this 20 and give it to the one, give that 1 that we borrow from the 20 to the 1/8. And when we say give, that means we add, right? So even though this is a subtraction problem, one of our steps is going to be to add the 1 that we borrow from 20 to the 1/8. All right. So let's see what that looks like. And actually, first, what I recommend is, instead of writing the problem horizontally like it is now, right now this is horizontal, similar to the x-axis on the coordinate plane, right? You got your y-axis and your x-axis. We're going to rewrite this vertically, similar to how our y-axis is. That's going to be important when you get into algebra and you start doing work with graphs and whatnot. All right, so let's rewrite the 20 and 1/8. That's our minuend. The first number in a subtraction problem is called a minuend. Minuend. M-I-N-U-E-N-D. The second number in a subtraction problem is called a subtrahend. It's the thing that's being subtracted. Subtrahend. Subtrahend. You should memorize that. So 20 and 1/8 minus 9 and 5/8. All right. So normally we would do 20 minus 9, get the 11, then 1/8 minus 5/8. Using this method, we can't do that using this method, right? We can't do that, so we're going to borrow from the 20. And now, also keep in mind, the denominators are already common. If the denominators were not common, we would have to first make them common. But in this problem, the denominators are already common. They're already both 8. All right? So what we got to do is, we got to borrow from 20. We're going to borrow 1 from 20. Not 2, not 3, not 4. We're only borrowing 1, right? We're borrowing 1 from 20. So that 20 is going to turn into a 19. So the 20 turns into a 19. When we borrow the 1 from 20, we got to add it to 1/8. But we can't just add 1 plus 1/8. We can't add a whole 1. We got to represent the 1 as a fraction. We got to represent the 1 as a fraction. This is the key element to these problems. We represent the 1 as a fraction. But you got to know what fraction to represent it as. It's not going to be 7 over 7. It's not going to be 10 over 10. It's not going to be 3 over 3. It's going to be a fraction that has the same denominator as 1/8. The same denominator as 1/8. And any fraction that's equal to 1 has the same denominator and numerator. So if I already know that my denominator's got to be an 8, and the fraction is equal to 1, then that means my numerator got to be an 8. So it's going to be like this. I'm adding 8/8. Any fraction that's got the same numerator and denominator is equal to 1. If you look right here, I got a list of a bunch of fractions that are equivalent to 1. 2/2, 3/3, 4/4, 5/5, 6/6, 7/7, 8/8, 9/9, 10/10, 11/11, 12/12, 13/13, 14/14, 15/15. All right, and it goes on and on and on. A million over a million is equal to 1. A billion over a billion is equal to 1. All right? You just got to know that when you're dealing with a fraction that's equivalent to 1, that fraction must have the same number in your numerator and denominator. All right. And why do we pick 8/8? Because we need a fraction that's got a common denominator with 1/8. So we can't add this. We're not going to add 1/8 plus 7/7. They don't have common denominators. We're not going to add 1/8 and 2/2, so 2 seconds. They don't have common denominators. We're not going to add 1/8 and 4/4. All right. They don't have common denominators. 8/8 has a common denominator. 8/8 is equal to 1, and it's got a common denominator. So those are the two things you want to look for. When you borrow from the whole number, and then you add to the fraction, you need a fraction that's got a common denominator with this fraction and is overall equal to 1. In this case, 8/8. So then I'm going to draw an arrow. And now that 20 is now not a 20 no more. Now it's a 19. So this is going to become 19 and 9/8. Now, make sure we understand. Why is this 9/8? Because I did addition of the fractions. I had 1/8 and I added 8/8. So altogether, my sum is going to be 9/8. That's how many eighths I got. I got 9/8. So 19 and 9/8. This down here is not going to change. This 9 and 5/8 is going to stay the same. So I got 9 and 5/8. I do my subtraction. 19 take away 9, that gives me 10. 19 take away 9 gives me 10. Then I do 9 take away 5, which gives me 4/8. Now I got 10 and 4/8. Now it looks like I'm finished, but I'm actually not. I'm not finished. And how do I know I'm not finished? I know I'm not finished because this fraction can be reduced. And how do I know that that fraction can be reduced? Because 4 and 8 have a greatest common factor that is not 1. When fractions cannot be reduced is because the greatest common factor between the numerator and denominator is a 1. But there's a bigger number that can be divided by each of these evenly, the number 4. And actually the number 2, these can be divided by 2 also, but that's not the biggest number. You want to go for the biggest number, because if we divided each of these by 2, we would just get 2/4. And then we'd have to do it again, because 2/4 can be reduced. So that's why it's helpful for you to just go for the GCF, or the greatest common factor. GCF is an acronym, stands for greatest common factor. Divide both of these by 4, right? Divide both of these drawings by 4. So 4 divided by 4 and 8 divided by 4. 4 divided by 4 gives you 1. 8 divided by 4 gives you 2. So your final answer reduced, or after you reduce, is going to be 2 and 1/2. I'm sorry, not 2. I said 2. I'm tripping. 10 and 1/2. 10 and 1/2. So that means that 20 and 1/8 minus 9 and 5/8 is actually 10 and 1/2. All right. So use this video as a guide, but as I always say, the key is for you to get your own independent practice. You need independent practice. That's how you really master math. That's how you become proficient in the language of mathematics. You got to get the independent practice. A lot of people, they get exposed to good teaching in classrooms or whatever. But if you don't get the independent practice, you don't do the homework, you don't do the practice in class, you don't do the practice on your own time, most likely you will not get it. And you will forget what you learned and what you saw in class. You have to get the independent practice. So ask your teacher, ask your professor, whomever for independent practice problems. If you're not able to get any from them, go online and just do a search. Do a search for subtracting mixed numbers with borrowing problems. Or type in the word worksheet and a bunch of links will come up from all over the places. The internet is full of practice problems. Take advantage. All right? So go get some practice, and I will catch you on the next video. Shout out to all the HBCUs. I graduated from 2 different HBCUs. I attended 3. I attended Morehouse as a freshman before transferring to Morgan State, where I matriculated, got my bachelor's degree back in 2003. Then years later, I earned the master's degree from Lincoln University, and now I teach at Cheney. So I'm all HBCU'd out. I got love for HBCUs, no matter which one they are. You know, I think they're valuable institutions where some positive things can happen. All right. But as I said, go get some practice, and I'll catch up with you on the next video. Peace.